Now that we know how Python evaluates constants and variables, let's turn our attention to operations. We have already seen many examples of binary operations. Here is one more example. If we run the simulator one step at a time, we can see something strange. We want to evaluate 5 plus 2, but LWPS pushed add 5 2 to the expression stack. What is add 5 2? And why did LWPS push this instead of 5 plus 2? Add 5 2 is a function call. Like operations, function calls are expressions, which means that they process input and produce output. Consider the following example. This machine called add takes two inputs, adds them, and outputs the sum. The inputs are 3 and 5, and the output is 8. Programmers refer to inputs as arguments and output as the return value. A function call consists of the function name followed by the arguments. The arguments are separated by commas and surrounded by parentheses. Here is the same example written as a function call. The function name tells Python how to process the input, just as the operator tells Python how to evaluate an operation. For example, if the function name is underscore underscore add underscore underscore, Python will add the arguments. Function names don't have to begin or end with underscores. Function naming rules are actually the same as variable naming rules. Here are some examples of valid function calls. And here are some invalid ones. The last example is an operation that adds to and number. The add function has underscores to indicate that this is a special built-in function. As we saw, if we ask LWPython to evaluate 3 plus 5, it will first convert the expression to add 3 5, then evaluate the function call. Can't LWPS just evaluate operations? Yes, but by converting operations into function calls, LWPS can use a single machine to evaluate both operations and function calls. Operations are just another way to write function calls anyway. Note that all operations can be converted to function calls, but most function calls cannot be converted to operations. Next, let's try converting nested operations into function calls. Here's an example. Let's start with the leaves and build up. In this example, the innermost operation is x plus y. LWPS converts this to add xy. Then we add z to this expression as follows. Let's try one more example. 3 plus 4 plus 11 plus 23. First, convert the child operations. Here we have add 3 4 and add 11 23. Then we just add them together. Other operators also have functional equivalents. Here's add, subtract, multiply, divide, less than, greater than, less than or equal to, greater than or equal to, and finally equal. These built-in functions are only available in LWPython. They won't work in real Python. However, real Python does provide built-in methods with the same names. We will study methods later. Next, let's take a closer look at how LWPS evaluates operations, starting with the conversion to function calls.